A confident, experienced developer can be scary, writing poems of code with deadly effectiveness. But what's one thing that could be even more dangerous? A developer with more confidence and less experience. What does that experience teach you? No matter how confident you are, no matter how sure you are, no matter how great your code is, something somewhere will blow up, and it's likely to come from the part you least expect it to. Anyone who's ever been involved in software development will tell you their list of what's essential. Business people and anyone with a visual background will tell you it's UI and usability. DBAs will tell you it's the design of the database structure. Someone from marketing will tell you that it's how good the software looks and what features are included. An experienced developer will tell you that one of the criteria of good software is how well it handles exceptions and errors. More importantly, how does it recover from those? For those of us that have seen specification documents for new software, it usually has over 80% of the content documenting features, the UI, reports, and other thing that pertains to the software's user functionality. Exceptions and error recovery are sometimes no more than a footnote or a paragraph somewhere. I remember this definition years ago in such a document. It read, software must recover from any possible error or exception. And in the same document, all the estimates said that over 80% of the work was implementing the features themselves. I don't recall seeing any significant estimate over the error handling itself. I labeled this as a high confidence, low experience point of view. Anyone with experience knows that Murphy is hiding behind every function, and anything that Murphy can mess up, Murphy will. So how do you fix this problem? How do you attack a project with error handling in mind so that you have something that is at least good enough, if not great? As one character in a sci-fi movie once said, the key to avoiding a trap is knowing of its existence, or something like that. If you know the movie I'm referring to, let me know in the comments. Error handling is a fundamental part of software development. If you're developing what is intended to be a robust application, then error handling is not something you can simply not do. One of the things that is crucial is that you implement good error detection technique. Good examples of this are, for instance, input validation. You must verify that input from any source, not just the UI, including users' data from other systems, meets the expected format, type, and range. You should reject invalid input to prevent errors arising from unexpected or malicious data. Another example is logging and monitoring. You should implement comprehensive logging to record events, especially around critical operations. You should also use monitoring tools to track system performance and behavior so that you can detect any early anomalies or unexpected patterns that may indicate errors. Another example is unit testing. A great way to detect errors. You should ensure that each part works correctly in isolation, which can help catch errors early in development. If you know what values need to be sent to a function, send those values and send values outside of this range. See if you handle at least the most obvious possibilities. After unit testing, you can perform integration testing to ensure the application's different parts work together as expected. This will help detect errors due to the interaction between the various components. Code reviews and pair programming are often options that are overlooked. As the old saying goes, two heads are better than one. Depending on the language and the tools, you may have access to static and dynamic code analysis. Code analysis can yield some interesting results. I'm not fond of them, as some tools will produce more vanity metrics than anything else, but they can be beneficial when used correctly. Some open source projects can be compelling error handling frameworks. Consider using some of those if it makes sense. Reinventing the wheel is a very common thing among developers. It's also, in my opinion, a very bad habit. Using what's out there, even if you didn't invent it, is good. And it can increase your velocity, creating more value in less time. Another type of test that's often overlooked is what we call boundary testing. I mentioned this in the scalability video has an essential test. What's the maximum number of user transactions and loads your application can support? If you are utterly clueless about these thresholds and limits, which may overwhelm and ultimately crash your application, well, your application is not production ready. It's a good prototype at best. Incidentally, in my experience creating and supporting enterprise applications for Fortune 500 companies, someone on the customer side will always ask what those numbers are. So make sure you have them ready. If you don't have them ready, then the risk management person will scribble a couple of notes there. You want to avoid that. Finally, regression testing is also necessary for the more seasoned applications that have been around for a while. The new code must play nicely with the existing code as the application evolves. This is what regression testing will tell you now and as we advance every time you run those tests. Good error handling means that errors will be handled gracefully and in a way that'll minimize impact on the user experience and the system stability. Also, having descriptive errors is a must. When an error is reported, it can't be cryptic. Sufficient information has to be included to identify the possible causes. People who see these errors may be looking for solutions in the documentation, and if those can't be found, then they likely will escalate to support. If support can't help, it'll be escalated to a developer. This is why you want to avoid cryptic error messages, which can be a massive waste of time. When QA tests the application, they'll likely trigger errors that no one expected. Likely, these are errors that are not handled. Well, just implement proper error handling in those use cases. It's a good practice, including proper descriptions and adding them to the documentation. You'll never have 100% error handling coverage in your code, but you'll eventually get very close by iterating. When an error occurs, handle it, document it, and move on. How about the developer? You're the most important cog in the process. If you use these learning opportunities, you'll gain experience and improve yourself. And in turn, you'll be able to improve the software itself and the development process.